Hey there, geometry. We are in lesson 14, putting it all together. So, to start out, sometimes in class I do this, and when we're meeting face to face, I will do this as a project, which is so much fun. If we aren't meeting face to face, then we just talk about it, which is not as much fun, but still can be a little bit enjoyable. So at a pizza restaurant, a personal pizza has a radius of 10 centimeters and costs $5. So that is, my tablet's not working. I'm going to pause this and get my tablet working. All right, it's working. That would be a pizza. Oh my. Sorry. With a radius of 10 centimeters and a cost of $5. Another restaurant takes a pizza with a radius of 30 centimeters, so it should be 3 times as big. $30 centimeters and cuts into, we don't have this, 8 slices of equal area. So that's 8 slices and charges $5 per slice. Ooh, slice. And this one is $5. Which is a better deal? Explain your reasoning. So we could talk about the area. Pi r squared $5. This would be maybe the area of a slice. So the area of the sector, we would call it, is pi r squared times 1/8. I think I can just do 1/8 of the pizza. So what would this be? I don't have my calculator. I'm going to pause a little bit so I can get my calculator. All right, so I got my calculator. This right here is 112.5 pi. The area of this is 100 pi. The area of this is 112.5 pi. So essentially, we know that the area of this one is greater. So this is the better value, right? Because you're getting more pizza. Even though you're just getting a slice, you're actually getting more pizza because 1/8 of this pie is bigger than the entirety of that pie. Okay? That's fun. All right, Pizza Palooza. So Alina was researching offers for the upcoming Pizza Palooza festival. She wants to get a good deal on a single slice of pizza. Your teacher will give you cards that show the deals offered by 4 vendors. Which vendor should Alina choose? Explain or show your reasoning. Here is another instance where I'm going to put a Google Doc together that will be graded as a homework assignment for you to explain your thoughts. Okay, this is again a fantastic student task statement to do together in class. Not quite as fantastic to do if we're not visiting each other face to face. So if we're face to face, we will take a break and do this one. It's going to be really, really cool and very, very rich assignment. If we're not face to face, then we'll have to take a break and go to that Google Doc. Okay? So whatever we're doing, that's what you're going to be in charge of. Hold on. Whew. Okay, Let me pick one of these optional ones. I'll be right back. All right, let's try student task statement number 4, because 3 and 4 were both optional, so let's just pick one. Noah is taking photos of a sculpture he made in art class. He will submit the photos to a contest. The sculpture is in front of a backdrop, which is represented from an overhead view in the image by segment AB. Noah positioned a light at point P so the edges of the light beam meet up exactly with the backdrop of segment AB. Noah wants to try different positions for the light to highlight different sculpture, but Noah wants to try different positions for the light to highlight different sculpture, but he still wants the edges of the beam to exactly meet the endpoints of the backdrop. Find at least 3 other places Noah can place the light. Explain or show your reasoning. So what I did here, I went to our answer key to look at it. Okay, sorry for that. And what we see here is we've drawn a circle. So we've inscribed our triangle here, essentially, and made A and B on the edge of the circle. And what I see here is I have a perpendicular bisector through AC and a perpendicular bisector through BC, and found the exact center of where those intersect. So that means if I did a perpendicular bisector through AB, that should just be 3 ticks. I would have a line right there. Okay, is that cool? So if we inscribe our circle, so we draw a circumscribed circle around the triangle with angles A and B on the circle, we can see 3 different points where this solution will work. Okay, let's look at it. So if we continue to look at this circumscribed circle right here, well, my head isn't, really any point on the front side of the backdrop, if this is the backdrop, is going to work. Okay, any point on this side of the backdrop is going to work for this problem. Okay, we'll be able to see sculpture on the front side of the backdrop, right? And honestly, this one right here, because we don't have to do all of them, Jada and Andre, big slice of pizza. If this were a slice, the pizza slice is a sector of a circle, which that is, with a radius of 20 centimeters, and the central angle that measures pi over 3. How can Andre and Jada divide the slice of pizza into 2 equal pieces so that Andre doesn't have to eat the crust? And honestly, we would slice it this way so that we could make this an isosceles triangle, right? Where those 2 sides are equal and those 2 angles are equal, calculating the area of this with the area of that, right? All right, let's see if we can do this. So I changed that to blue. We're going to keep the whole thing. Okay, not that picture. 20 centimeters, 20 centimeters. So if we had the area of this, okay, this would be pi over 3 over 2, because we just cut it in half. So that's pi over 6. So I'm trying to figure out the height here, which we learned in our last unit. That height is, if I want of this angle, adjacent over hypotenuse. So adjacent over hypotenuse is ca. So cosine of pi over 6 equals adjacent over hypotenuse. if you go into your calculator, please make sure your calculator is in radians. So that just means our mode right there, that's in degrees. I had to go down and select it into radians. So I'm going to quit and say cosine of pi over 6, see it, times 20. That is 17.3. So the height is 17.3. So the area of this triangle is 1/2 base times height. I don't have the base either, do I? So here, if I have base over 2, let's just call that, I don't know, y. So that would be theta opposite over hypotenuse. So that's sine of pi over 6 equals opposite over hypotenuse, y over 20. 20 times sine of pi over 6, sine pi over 6, sine pi over 6 times 20 is 10. If you look right there. So that's 10. The whole thing is 20. The area is 1/2 base times height. So the area of that is centimeters. So if I continue on here, you see the area of the slice with a radius of 20 centimeters, just without the crust, is 86.5 centimeters squared, which I just redrew here. So 86.5 centimeters squared. And if I draw the crust on there, that is not 86.5 centimeters squared. So really what we're looking at doing is trying to find, if this were a circle, a whole circle, where the area of the sector is equal to the area of the crust. So we would actually draw where this is an isosceles triangle, and this is still pi over 3, right? And those two segments are equal, but we're trying to find a way for, what are their names? Jada and Andre, so that the area of the sector is equal to the area of a piece of the pie plus the crust. Okay, not actually an easy thing to do. All right, it was a great exercise working through this. Okay, that was not useless, but it doesn't actually help us solve the problem. So conceptually, what we're thinking about doing is we have an isosceles triangle, which we know how to solve. How can they divide the slice of pizza into 2 equal pieces so Andre doesn't have to eat any crust? It would be like this, where Andre gets this piece, and Jada? Yes. Jada gets the crust plus a little bit of the pizza. Okay? Cool. Good job.